Okay, welcome back, Chapter 5. This is still what I've called Part 1 of Chapter 5, dealing with the single-dimensional spatial model. But now we are going to actually start calculating people's, what we're going to call preferred to sets. And it means exactly what it says. It's the set of things I prefer to a given alternative, right? So you give me an alternative, these are all the things I like better than that alternative, all right? That's what a preferred to set is, okay? We're often going to want to know what alternative a voter would vote for when compared with some given alternative. There's usually going to be a status quo policy, and someone's going to make a proposal and say, I propose we do this instead of what we've been doing. And they're going to have to vote. And the way we're going to operationalize that voting in our spatial voting model is that we're going to look at which alternative gives them the most utility. They will vote for the alternative that gives them more utils, all right? Now that we've simplified utility down to just distance, they're going to vote for the alternative closer, all right? So what we're going to want to know often is, here is the standing status quo alternative. What are all the things this voter prefers to that status quo, all right? We're going to call that the preferred to set. So here's a graphical example. Here's Adam, and here's an alternative, 70%. Adam likes 50%, all right? 50% is Adam's ideal point. If we drew in the utility dimension, it would be the peak of his utility function, and we're assuming symmetric single-peaked utility. Adam's utility would fall away. It might be a curved utility function, or it might be one of those cone-shaped utility functions, but Adam's utility falls the same as we move the same distance away from his ideal point. So here is 70. All right, so what I want to know is, what are all of the alternatives that Adam likes better than 70? All right, what are all of the things he would vote for over 70%? All right, so what alternative does Adam like better? He definitely likes everything between 50 and 70 better. Note, we are getting closer to his ideal point. Therefore, if we drew in a utility function, imagine one of those mountain-shaped utility functions, we would be climbing up that utility mountain. I don't have my little digital pen hooked up right now, so I can't draw that in. But it makes sense that moving from 70 toward 50, Adam doesn't like 70 that much, but if you move closer, 60, Adam likes better than 70. He likes 55 better than 70, and he likes 50 the most. So he definitely likes all of those things better. But there are other things, there are other alternatives in this issue space that Adam also likes better than 70%. Not just these, where we can clearly see we're getting closer to his ideal point. All right, remember his utility function. All right, and let me put it in there. So here is how much Adam likes this alternative. So every alternative that would give him utility that is above that level, he likes better. So here is what we would call his indifference point for 70%. He is indifferent between 30% and 70%. If we ask him to vote for it, he wouldn't know what to do. He might flip a coin, but he gets the same exact utility for everything. He gets the same exact utility for 30 and 70. I almost said the wrong thing there. All right. So what is the set of things he likes better? Well, we said he definitely likes all these better. And notice all of those alternatives give him utility, right? 60 gives him this much. 65 gives him this much. 55 gives him this much. All the points between 50 and 70 lead to higher utility. And also all the points between 30 and 50 lead to higher utility because he has symmetric and single-peaked utility. So what is the set of all things that Adam prefers to 70? That set of things is everything between 30% and 70%, not including 30 and 70. 30 and 70 are in his indifference points. They are not in the preferred to set. They are his indifference points. They're his indifference set, you can also say. All right. So the set of alternatives Adam prefers to 70 is the set of points between 30% and 70%. Between, not including 30%, not including 70%, but between them, all right? So 30.00000000001 is in there. That's in the preferred 2 set, but 30% is not. 69.9999999999999 is in the preferred 2 set, but 70 is not. Those are his indifference set, 30 and 70%, or his indifference points, okay? So this is how we write it. The preferred 2 set of atom, that's a subscript, the preferred 2 set of atom, you might just have a capital A if you're abbreviating, of the alternative 70% is everything between 30% and 70%, and notice I have the soft brackets, or these parentheses, meaning 30% and 70% are not in the set. If they're in the set, you do a hard bracket, right? Or a square bracket. But these are not in the set. So when we use notation for set notation, a parentheses means it's not 30%, but it's everything right up to 30%. It means it's not 70%, but it's everything right up to 70%. All right? And I'm going to show you some examples where we do have hard brackets in a second, so that distinction will become clear if it's a little bit confusing right now. So notice all that matters is distance. 50 to 70% is the same as 50% to 30%. So we can get rid of all of this stuff up here. We don't need the utility dimension. All we really need is distance from the ideal point. This is because his utility is symmetric and single-peaked. All right? We don't need to see the utility function to find the preferred 2 set. All right? So we could just have drawn it this way, knowing that if I tell you in the problem that the agent has symmetric single-peaked utility, show me the preferred 2 set for atom for 70%, all you have to do is say, I know he likes all of these better, and I know he likes all of these symmetrically on the other side better also. The reason though, and don't forget this, is that single-peaked utility function, okay? So let's try another one. Here's Carrie, and Carrie's ideal point in this issue space is 20%, all right? And there's an alternative, 40%. So we want to know what is Carrie's preferred 2 set of 40%. What is the set of all alternatives that Carrie strictly likes better than 40%, all right? Well, she definitely likes everything between 20% and 40%. We're moving closer to her ideal point, right? We would be going, if her utility function was drawn in here, we would be going up that utility mountain, right? So she definitely likes all of these better. But we know she has symmetric and single-peaked preferences, so we need to find the set of things on this other side she also likes better, all right? So go the same distance in the other direction, so 20 to 40 is 20. So go 20 in the other direction to 0, and that is her indifference point. So 0 and 40% are her indifference set, and everything between 0 and 40, not including 0 and 40, are Carrie's preferred 2 set for this alternative. So the set of alternatives Carrie prefers to 40% is the set of points between 0% and 40%. And we write that out notationally like this. The preferred 2 set of Carrie, and again, this is a subscript of 40%. The alternative 40% is everything between 0 and 40%, not inclusive. The soft brackets or the parentheses mean 0 is not in the preferred 2 set. 40 is not in the preferred 2 set. It is the boundary of the preferred 2 set. These are the indifference points, or the 2 points in the indifference set, okay? All right, so again, I'm going to break this up into chunks. Even though we're still in part 1 of what I've called part 1 of chapter 5, we'll come back, and now the next thing we're going to want to know is, okay, that's what people prefer. What things are going to beat an alternative? If we're voting, what things are going to beat it in a vote? All right, and that's called the win set, and we'll come back to that next.